This is a lab exercise captured on video on the topic of MEMS sensing application, taken from the Lab 5 of the Dreamcatcher, ME5000 University Courseware. We are going to use the B2902A Precision Source Measure Unit to determine and measure the movement of the ME5000 sensor board with two axes of the accelerometers and gyroscopes responses. To get the most out of this lab exercise, you should view the video along with the lab sheet. Please download the lab sheet from this link. Gyroscope is used to measure the angular velocity. Using the value integrated over time, we can obtain the sensor's tilt angle. By using 3 gyroscope sensors, and putting their axis of measurement orthogonal to each other, we can obtain the roll, pitch, and yaw angles. The movement of an object with length r can thus be estimated in the form of spherical or Cartesian coordinates. ME5000 experiment kit contains one static probing board and one removable sensor board. In this experiment, we will use Keysight Quick Form Measurement software and Keysight B2902A Source Measure Unit to capture the angular velocities from the ENC03RCD gyroscope, which is located on the ME5000 sensor board, and then calculate the pitch and yaw angles. Now, let's see how to set up B2902A SMU and ME5000 experiment kit. Connect SMU channel 2's high force to J8 test point, which is gyroscope's Z-axis signal, on the probing board. Connect SMU channel 2's low force to GND1 ground point on the probing board. Connect SMU to a computer using the provided USB cable. Connect SMU channel 1's high force to J9 test point, which is gyroscope's Y-axis signal, on the probing board. Connect SMU channel 1's low force to GND2 ground point on the probing board. Connect the sensor board to the probing board using the provided micro-D to VGA cable. The jumper setting on the J2 pins must be set to right position. Remember to power up the probing board using the provided DC power adapter. Now, let's see how to configure Keysight Quick Form Measurement software. Once Quick Form Measurement software is fully opened, click the Add SMU button twice, to add 2 SMU devices to the measurement window. Select SMU1 on the measurement window, and click Search SMU button under the SMU connection panel, for choosing the appropriate USB interfaced SMU model. Once the hardware address of SMU1 is set, choose channel 1 as the channel source, and then rename SMU1 to Gyro Y. Repeat the same steps to configure SMU2 for channel 2, and rename it as Gyro Z. To change the individual SMU settings, first, select Gyro Y, and choose SMU setting panel. Change Gyro Y's mode selection to I. And then change the compliance voltage to 5V. Repeat the same settings to Gyro Z. Next, change the VAR1 value under the common sweep setting to 2500 and the repeat value to 4. To start measurement, we must first configure the graph settings. Change the X data option to gyro Y time and the Y1 data type option to voltage. Ensure the Series 1 data option is set to gyro Y voltage, while Series 2 data option is set to gyro Z voltage. You may now click the Measure button to start measuring the gyroscope sensor. Perform a combination of pitch and yaw movements, as shown on the sub-screen. Once the desired gyro Y and gyro Z signals are captured, click Stop button and switch to Table View to examine the measurement data. To remove the unused columns, which are gyro Y current and gyro Z current, right-click on the table and choose Column to disable the current information. To further analyze the measurement data by using Scilab Numerical Computational tool, we need to first export the data into a Microsoft Excel spreadsheet. First, highlight the entire table cells, and press Ctrl+C to copy all cells into Windows Clipboard. Open a blank Excel spreadsheet, and press Ctrl+V to paste all the copied cells into the spreadsheet. Save the spreadsheet as Test 1 in Office 2003 workbook format. Open a blank SciNotes in Scilab console, and key in the sample codes given in the lab sheets. The codes are used to first convert the measurement data into pitch and yaw angles, and eventually be further transformed into three-dimensional motion. Update the file name and the path of the previously saved spreadsheet, test1.xls, in the codes. Enter the total number of records in test1.xls, at line number 4. Click the play button to save and execute the codes. The graph shows the three-dimensional plot of the ME5000 sensor board's movement in Cartesian coordinate system. In this experiment, we have learned how to use B2902, a precision source measure unit, and quick form measurement software to capture the two axes of the gyroscope's responses. With the aid of Scilab Numerical Computational tool, we have also learned how to convert the measured signals into tilt angles, and eventually represented them into 3D motions in Cartesian coordinate system. Thank you for viewing ME5000 Lab on video. For more labs on video, please visit